This is a question from the 4.5 homework. I think it's the first question. They give us a function that has a decimal value inside of it, the coefficient a of negative 0.05, or it could be different depending on your question, but it does have a decimal value in it. And they would like us to get the exact value using the quadratic formula. So first of all, it's very difficult to use the quadratic formula with a decimal because we're not allowed to have a decimal inside of a fraction. So I want to take this equation and multiply by 100 to move the decimal place twice to make this a whole number. So I'm going to do that in the equation. I'm going to change the equation to y equals negative 5x squared, and then plus, I need to multiply by 100 over here as well. And so what I'm trying to show is that the equation is different. The green line and the blue lines don't match, but they still have the same x-intercepts. So if I solve this new equation, negative 5x squared plus 3,000 multiplied by 100 multiplied by 100 on both of, not both sides, I didn't do it to the y side, but it has the same solution. So if I solve the new equation, I'm going to get the same answers as I do in the original. And now I'll be able to use the quadratic formula because I have whole numbered solutions. All right, so in our quadratic formula here, the b value is 0. So I have negative 0, or just 0 for the b value. And then we're going to have 0 squared, or just 0, minus for a c, the a value is going to be negative 5, and the c value is going to be 3,000. And then we're going to have over 2a, which is the negative 5 again. So we're just going to keep this on what am I trying to say? Keep this value in decimals here so we can verify that we have the same solution, and then we're going to get this simplified. There we go. So the radicand, or the discriminant, which is the inside of the radical, we can simplify that. And then we can change the inside of our radical to, looks like 60,000. And again, same thing here. And I know I can take this 0 plus off because I would still have 0, and I can change my bottom to negative 10. Okay. Continuing, I'm going to have to break up that 60,000 and a perfect square. So I could do 6 times 10,000 is 60,000. And this should be a perfect square. I can check by doing the square root of 10,000. It's 100. I knew it was going to be a perfect square because it had 4 zeros. And so 100 times 100 is 10,000. So that's one way of finding the largest perfect square that goes into it. So 10,000 is the largest perfect square that goes into 60,000. So we're going to continue, and oops, I didn't mean to paste that again. We're going to get this thing simplified further. The 10,000 is going to come out of the square as 100, and again, I'm just checking that my value is the same. And then we can reduce the fraction. So we'll divide by negative 10. When I divide the 100 by negative 10, I will get negative 10. 100 divided by negative 10 is negative 10. And so I end up with the negative 10 times the square root of 6 for this first solution. The other value, remember back up here, we had 0 plus, so now we're going to have 0 minus, and so it's going to be the negative of this, and so negative 10 square root of 6, or positive 10 square root of 6 should give us the other value, as you see that it does. So I'll take that double negative off now and just say it's the positive 10 square root of 6. So this is the way in which I can get the exact solutions to this equation. If I were working with the decimals, it's also possible to get there, but I'm going to have to eventually convert them into fractions because I'm not allowed to have a decimal inside of a fraction, and it's a little more complicated to do that process. We'll end up multiplying by the reciprocal of our fractions in the case of the division. So I do recommend going ahead and getting rid of the decimal first by moving it 2 places or multiplying by 100, because as you can see, the answers to the new equation are the same as the answers to the original equation. So we can solve the new equation and get the same answers.